Yes, let me continue. Yes, uh, is it audible now? Let me spend just 15 to 20 minutes just to explain the logic and to show the execution of the program. Is it audible now? Okay. Okay, fine. So I was just explaining this program. So you call the display functions with taking into the consideration. So hope the screen is visible and it is audible. Yes, so let me go fast once again before the any problem with the internet connection. So you call a draw tetra. So draw tetra uses 4 points. The 4 points, point A consists of the individual vertices of a tetrahedron internally consist of three coordinates. Remember here you have taken as a point, it is a type def of three variables, point def of three variables, point of 3, point of 0, point of 1, point of 2. So you have to consider point of v of 0, v of 1, v of 2, v of 3. So v of 0 is this, v of 2 is this, v of 3, v of 4. So using this you call a tetrahedron. Okay, here dot draw tetra, that is point of a b c d. So what I have shown on the screen, so these will be drawn. So that is the initial step of this. So this will with the red color, this with the blue, this with the green, and this with the, so the base color is white, so that you can see 0 0 0. So base will be the white. So initially you'll not be able to see the base color once you execute. So I'll not go with more explanation. So before we start with the program, so what is dt? So dt, you call dt with v of 0, v of 1, v of 3 with the number of divisions to be performed recursively. So this has been called many times with respect to the individual. So void dt, it consists of the 4 points with the number of divisions to be performed. It is a function call. If m is greater than 0, you have to subdivide. So if imagine if m is not greater than 0, simply draw the tetra. Simply draw the tetra. What is the tetra? Tetrahedron with ABCD. What is that tetrahedron ABCD? ABCD is over here. So with the 4 points, if you are not going to perform any subdivisions, if you are going to perform subdivision, that is if the value of m is greater than 0, then we have to do the you need to find the midpoint of individual triangle, and you have to subdivide it, and you have to assign as v1 of j. So let me not waste the time. I'll simply go to the execution of a program. I'll explain once again in the one of the theory sessions this program, right? So this is a program. So I'll share it to you. Still more, the division of the Sarafinsky gasket is there. So here is a program. So initially it will ask you, you have to debug, then you have to execute. So this will be the program. So understand there is a problem with the sharing of the screen. Uh, so as explained you, so this will be the red, blue, green. You have to, if the recursive subdivision has not to be performed, so that time you will have the uh, all of you just a lot of network issues, so maybe I don't want to continue because I'm not be able to uh, do the class properly. So I'll take one more session on this. I'll inform you maybe in the theory class itself. So you could see here, I don't need any sort of attendance as of now, so attendance is not mandatory for me. So all of you just try to focus on this program. I'll explain the logic of this program once again. So drawing a tetrahedron is easy. You need not to give the attendance, as I said. So first you have to perform the recursive subdivision. So how do you recursive subdivision? That is an important topic over here. Identifying the midpoint of individual triangle, and you have to redraw it, all of you. So let us see here. How does this output looks like? So when you perform a division, that is a, recursive subdivision. So what it will identify, it identifies the midpoint of individual triangle. For example, here, it identifies the midpoint. From here also, and it is a top view, remember. So all these triangles are totally separated. Tetrahedron, tetrahedron. So this is important. Similarly, if I do a recursive subdivision, so this will be the program. So recursive subdivision, how does it happens usually? Take into the consideration individual triangle. Okay, this triangle, this is a separate triangle. So initially, no triangle is being formed. No recursive subdivision will be done. So you simply have to draw a tetrahedron. Simply have to draw the tetrahedron. Okay. So in theory, I'll explain once again this class, the logic of this program before I start my second module. Okay. So thank you for joining the session. Thank you for joining the session. So there is a network issue. So let me do one more session on that. But before that, I'll just post up this program, you execute, so that I'll explain once again how does this recursive subdivision happens with respect to the tetrahedron. Thank you.